Hi, y'all. In this video, we are going to extend our 3D demo project, and we're going to make it so that this character follows the mouse as it rotates around. And then we're going to have to adjust our movement so that when we move it, it doesn't just move on the coordinate plane, then it actually goes forward for wherever the mouse is. So it's going straight when we tell it to go forward, not always up and down. Okay, the first thing I want to do is clean this up. Forward is going to be that z-axis, so I want to move these eyes a little bit. So I'm going to bring that one over there, and there we go. And maybe I'll move that one up there. I don't really care which one is the right eye or the left eye. That's okay. I think that'll do. If I really want to be able to see what's going on, I could bring the eyes up a little bit out there. That looks a little weird, but we could fix it later if we care to. All right, so getting it to follow the mouse around is going to happen in our player script. And what we have to do is arrange our mouse to figure out, and we see that I've already got the code here because I crashed earlier. I'm just going to undo that stuff, and I'll cut it out of the video later. And we're back. Okay, so the first thing we want to do right now, all we've got is we're grabbing the information from the keyboard or the controller or whatever it is and moving the player on the X or Y coordinates to match. But now we want to have some mouse control to determine which way the character is looking. So I'm going to put in a comment here to say that we are working on mouse control, and I'm going to put that there. So the mouse lives on a two-dimensional plane that is the screen, and ours is now a 3D world, so it's a little bit more complicated than it was before. So for the mouse, we get a vector 2 because it's just a two-dimensional plane. So mouse position equals mouse.current.position.read value. And that'll get us where it is. And then what we have to do is to define array that'll go from the camera through the mouse position and into our world. And we'll use that to figure out where it hits some object in our world, and that'll tell us where we're going. So we're going to say ray equals camera.main.screenPointArray for the mouse position. All that help I got there, isn't that lovely? That defines the ray. And then we have to create a variable to hold the results of the casting of that ray. So that's called a ray cast hit. And there is a Y in ray cast hit. And we're just going to call that hit. And then we say if physics.raycast, that's got a capital R, ray, and then we've got this out hit. So normally when we've called functions, those functions return a value, and we would say something like n equals input, what do you want to do, right? Or n equals random.range 100. In this case, it's going to change the value of this variable inside of the function, and we just grab it that way. It's a weird way to do it, but it does work. And so if this works, so physics raycast returns a Boolean based on whether or not it ran into a collider somewhere in our world. If we're just staring off into space, it could be anywhere along that ray and it can't tell us anything. So that mouse has to be over some object in space. So then in here, if it did find anything, we can say transform.lookat, And we can just say hit dot point, because the point that it gives is the spot where it ran into an object, a collider in our world. Let's go look at the results of that, and then we'll come back and fix it, because it's not going to make us happy. All right, here we go. It is looking, it's turning with the mouse. Very nice. But notice that it is also looking up and down. Always at the ground, because that's where the raycast hits, but we don't want our character to be doing this flipping around thing. That's weird. We want it to be flat. So instead, we're going to adjust that to control the y-axis of that look at. So we're going to look at, let's actually create a new vector 3. Vector 3 look position equals new vector 3. No, it's trying to help me in ways that I do not like. Vector 3 look position equals new vector 3. No, new vector 3. There we go. Hit dot point dot x. We do want its x. We want our own y. And then we're going to bring in the hit points z. The hit point does have an x, y, and z, but we don't want the y. So we're going to come back here and we're going to get rid of system numerics that it added while it was trying to help me. Very helpful. And then we're going to look at not that, but at our look position. Okay. And then we come back here and we're going to test it out. And hopefully our character has its balance back. There we go. Now we want to do another test. And that involves giving us a little bit of context so that we can see what's going on. I'm going to go ahead and put a cylinder in place here, and I'm going to move it over here and here. And I'm just going to duplicate it so that I've got maybe another one somewhere. Gives me some room to move. So I'm going to press the W, and we'll see what the results are for our player character. I cannot move. There we go. W goes that way. So what's happening there is that my friction is not, there we go. My friction is not combining correctly. I think I lost a setting in between. So when I hit S, it always goes this way, even if I'm looking this way, right? So it is still moving based on the regular coordinate plane, not based on where the character is looking. We've got some work to do to make that happen. The first work that I'm going to do, though, is go into materials, and I'm going to go ahead and make that friction combine the minimum so that I don't have to jump around. I'm going to play again to check that this is right. Okay, so if I press W, it goes straight back, even though I'm looking the other way, and it doesn't matter which way I'm looking, it always goes there. So if I hit the D, well, let me get back in space. If I hit the D, it goes to the right, even if, so I'm going to stop it, come back into the zone. There we go. Okay, so I'm pretty well stopped now. I'm looking straight towards me. If I'm looking away, I'm looking to the left. There we go. If I hit the D, I'm now traveling backwards because it's only on the coordinate plane. It doesn't care which way we're looking. It always travels the same directions for those. That's not how I want this player to move. I want it to move in the direction that it's looking when I press W. So in order to do that, I have to do some math on this move direction here. So I'm going to comment out that line, and I'm going to say vector 3 move direction. And we've got a couple of convenience features here where we can say transform.forward. And that means the way that whatever the object is we're on, the way that it is looking, its version of forward. And our inputs are some value on the y that represents that forward amount. If it's +1, I want to be going straight forward. If it's -1, I want to be going straight back. So I can say move input dot y is our forward amount. And then I'm going to add to it the right and left amount, because there is also one called transform.right. And I'm going to multiply that by move input.x. So I get that adjusted based on the inputs and the direction that the character is looking. So that's pretty good. And then I'm still moving in the move direction. Let's see if that gives us what we want. We may have to do some multiplication of speed and such because I'm not using it right now. But if I'm looking sort of diagonally here, whoa, I'm go very, very fast in that diagonal direction. So now what we're going to do, because this is all working together, so we're going to say move direction times time dot delta time times speed, and bring those controls back into place to smooth everything out and put it directly under our control. There we go. So now let's go here. And I'm only pressing the W now, and we can see that it is adjusting the direction of movement according to that. I can add some friction if I want, or some linear damping to make sure that it doesn't quite so slidey, doesn't take quite so long to get there. But now I've got movement going the way that I want. If I go to the right on the D, I'm going to the right. I should be coming back towards my, there they are. Okay, I'm going to play around with the friction just a little bit. Let's add just a little bit of friction so that I do have some stopping power. There we go, that's a little better. There we go. So I can stop if I want to. I could do some things with like a space bar on the jump stop, or maybe on the shift, but this is working pretty well. So now I've got motion based on the mouse and look direction based on the mouse instead of just on the coordinate plane. And that is what we're going for today. Thanks, y'all.